Good day, students. I hope everybody is doing great. Today, our main strand is fraction. Our substance here is addition, subtraction of fraction. So today we are going to talk about the fractions, how to add and how to subtract two given fractions. What we are learning here can also be verified from the new curriculum or the syllabus, the BSS, the strands 1, substrand 3, content standard 1, and then indicator 2. So we are using the indicator 2 of BSS, strand number 1, substrand number 3, content standard 1, and then indicator 2. This can also be verified from the BS5 syllabus, which is the BS5 curriculum, strand number 1, substrand 3, content standard 1, and then indicator 3 of the BS5. Good. Addition and subtraction of fractions. Addition and subtractions of fractions. To add or subtract unlike fractions or mixed fractions. Let's talk about some of them here. In order to add unlike fractions or unlike mixed fractions, you change all unlike fractions to like fractions first. You change all unlike fractions to like fractions. And when we talk about unlike fractions, they are the fractions with different denominators. Fractions with different denominators. Example, 2/5, 1/7, 4/9. You could see clearly that the denominators here are 5, 7, 9. They are the denominators. They are different. Therefore, these fractions are called unlike fractions. While like fractions are fractions with the same denominators, So examples of like fractions here is 1/7, 4/7, 6/7, 5/7. Now you can see clearly that the denominators here are 7, 7, which means that the fractions here are like fractions. We also have another terminology that we want to talk about, which is the mixed fractions. When you talk about the mixed fractions, they are the fraction with a whole number. Any fraction that has been attached with a whole number are called a mixed fraction. Example, 8 whole number here, 1/7. 8 whole number, 1/7 is also a mixed fraction. A fraction that has been mixed with a whole number. 4 whole number, 3/5 is also a mixed fraction here. 1 whole number, 1/2 is also another mixed fraction here. Changing unlike fraction to like fraction is to find the LCM of the denominators or find the LCD of the fractions and use it as a new denominator to express their equivalent form to get like fractions. Before you can add or subtract any two unlike fractions, the only thing that you have to do is that you change unlike fraction to like fractions. But changing unlike fraction to like fraction, the main motive is that we are going to choose a common, because unlike fractions have no common denominator. So you choose a common denominator for unlike fractions so that they become like fractions. By using the LCD or the LCM to choose a common denominator for that. After then, you write their equivalent or you rename the fraction using the new denominator that you have ascertained so that the denominator will be equal to the new LCM or the LCD. LCM, the least common multiple, the LCD is the least common denominator. So the common denominator that will be chosen for unlike fractions is the one that we are going to use as a new denominator. After changing to like fractions, then you add only the numerator and select one of the denominator if you are solving for additions or fractions, or if you subtract the numerators and select one of the denominators if you are solving for the subtraction of fractions. So after you have find your LCD or the LCM, then use the LCD as a new denominator, then you convert or you write equivalent fractions or rename the old one so that the denominator of the new fractions will be equal to the LCD. After then, since the denominators becomes equal, or since you're able to establish the same denominator, then you only add the numerator when you are dealing with the additions. You add only the numerator and then you choose one of the denominator which is the same. Or when you're dealing with the subtractions, you find the difference of only the numerator, and then you choose one of the denominator. Good. Let's try one more examples here. Example. Solve the fractions below. A, 1 over 2 plus 2 over 5. Then the B, you also talk about the difference of that. 1 over 2 minus 2 over 5. Good. Now looking at this one here, we have 1 over 2 here plus 2 over 5. These two fractions here are unlike fractions because the denominators are not the same. The denominators are the 2 and the 5. They are not the same. So these kind of fractions here are unlike fractions. So the best thing that you have to do is what? You change unlike fraction to like fraction. So you write change to like fractions by finding the LCD or LCM of the denominators, because we want to change the denominators. So you find the LCM of 2 and 5. So you find the LCM of 2 and 5. Good. And before you can find the LCM or the LCD of 2 and 5, we have two methods that we can use to establish that. The first one, we can use the multiples of, or the multiples method, whereby you list the multiples of 2 and then you list the multiples of 5. After then, you list the common multiples. When you talk about the common multiples, the number that appears in the multiples of 2 and at the same time appears in the multiples of 5. Within the common multiples, you select the minimum or the least or the lowest number in the common multiples, and that one will be the LCM or the LCD. After getting the LCM, that one will be the new denominator for the new fraction that you are going to write. So let's quickly use the multiples method, whereby you find the multiples of 2 first. starting with the 2, plus 2 will be 4, plus 2, 6, plus 2, 8, plus 2, 10, plus 2, 12, plus 2, 14, 16, 18, 20, 22, 24, 26, 28, 30. So you can also list the first 10 multiples, okay? You see this one is more, okay? The first 10 will be the 20. Okay, let me list up to the first 11, which is the 22. So you put 3 dots at the end, indicating that the multiples has no end, or the multiples are endless, or the multiples are infinite. Okay, so you can continue later. Then you list the multiples of 5. Multiples of 5. Starting with the 5. 5 plus 5 will give you 10. 10 plus 5, 15. 15 plus 5, 20. Then 25, 30, 35, 40, 45, 50, 55. And that will be the first 11 multiples of 5. Okay. Then you put 3 dots, indicating that the multiples has no end. Good. When you finish, then you list the common multiples. When we talk of common multiples, they are the numbers that appears in the multiples of 2 and at the same time appears in the multiples of 5. Because once you're done with the M, which is the multiples, then you come with the CM, which is the common multiples. So after the CM, then you list the least one in the common multiples. Now let's check the number that appears in the common multiples, or appears in both multiples of 5 and then the multiples of 2. Now we have 10 here. 10 happen to be the first common multiples, and then we also have the 20. 20 happen to be the second common multiples here. And then I think when you continue, we get more. But these are the one that we have within our multiples of 2 and then the multiples of 5 as far as the first 10 listed numbers are concerned here. So we got 10, followed by the immediate one is also 20. And then you put 3 dots, indicating that when you continue, you still get common multiples. Then within the common multiples, then you list the lowest in the common multiples, which is the LCD or the LCM, the lowest in the common multiples. And that one too is 10. Good. The lowest number in the common multiple, and that one too is 10. Good. Now, with this, the 10 is the lowest in the common multiples, and therefore our LCD is 10. What's the meaning of getting 10 as LCD or the LCM? Which means that we are going to write another fraction for this 1/2 and 2/5, but we will make sure that the new denominator will be 10 10 so that they will all be like fraction. Okay, good. So our new denominator will be 10 10 here. This time it's not 5 and the 2 again. Then this method here, we call the multiples method. We have another way of also finding the LCD or the LCM. That one we call it the prime factorization. Okay, we call it the prime here. Factorization method. Then that one we reduce the given denominators to 1. After then, the numbers that we use to reduce the denominators, you will multiply them to get your LCD. Just that. So let's assume that, or we will not even assume the number that we're supposed to find the LCD or the LCM is 2 and 5. Okay, good. Then we draw a table, nice table for it. And then good. Then with this, you choose a number that can cancel the 2 and 5 at the same time. Because this number is even number and this one is odd number, it will be very tough for you to get a number to cancel the 2 and 5 simultaneously. Then if you reach to the stage whereby you cannot cancel the two numbers at the same time, then you take the numbers themselves, because the main aims of using this method is to cancel the numbers to get 1. So since there's no number, it's not always that you have to use the numbers themselves. You have to think about the 2 numbers or 3 numbers. If you are finding the LCD of 3 numbers, you have to think about the 3 numbers, the common number that can cancel all. These are the 2 numbers, but we can't get a common number to cancel also. You have to take the numbers themselves. So the first digit here is 2. Okay, 2 cancel to 1. We have done with this one. 2 cannot cancel 5, so we have to repeat the 5 in the box. Okay, good. Then, since we're supposed to cancel to get 1, so you have done with the 2. Now, the 5. Is there any number to cancel the 5 to get 1? The 5 is 7. Okay, good. 5 cancel this 5 here. 5 cancel this 5 here. You get 1. Okay, good. We have done with that. Therefore, the LCM will be the numbers that we use to cancel those given denominators to get 1, the multiples of that. So here you write the LCD, which is the least common denominator, is equal to the numbers here, the numbers that we use to cancel the number, which is what? The 2 times 5. And that one is what? 10. Okay, so irrespective of the method that we choose, you still get the same as the LCD is 10, the LCD is also 10, the LCM is the same as the LCD. Okay, good. Now, after getting 10, 10, which means the new denominator for these fractions here is supposed to be 10. And that method, we call it renaming, which means that we should rename the fractions. We should rename the unlike fractions, and therefore the denominator choosing for them is supposed to be 10. Good. So we call it renaming. Good. This is renaming. So you are going to rename these fractions here. Now, when you take 1/2, you leave a space, then you bring equal sign here. The new denominator here supposed to be 10. Sorry, supposed to be 10. Then when you take the other fractions, which is 2/5, you leave a space here. The new denominator for this one will also be 10, because that's the essence of finding the LCD or the LCM. LCM means what? You're going to choose a common denominator for that. Now, the numerators here, we are now going to work for that, the new ones. Now, let's take something here. You are going to do small statistics. Now we have the old denominator is 2, the new one will change to 10. So which means that what number do you think you multiply by these two that you're able to get 10? That one is 5. Okay, good. Since the 2 times 5 give us 10, therefore the same 5 that we multiply by the denominator, the old denominator here, must multiply by the numerator here. Okay, so that we can also get the numerator here. So the 1 times 5 will also give us what? 5. Give us 5 here. Okay, good. Now, when you come to the other one, the old denominator is 5, and we said the new one is supposed to be 10. Now, you think about the number you multiply by the old one that you're able to establish the new one. So here times 2. 5 times 2 give us 10. Therefore, the same number multiplying must use to multiply the numerator here, so that you can get a number for the new numerator here. So here will be 2 times 2 will give you 4. Good. Now our new fractions here are 5/10 plus, because the first one that we are solving, plus 4/10. Good. Because the denominators are the same, then you choose one of the denominator here. Okay, and then you add the numerators. You add the numerators. You add the numerators. The numerators are the 5 plus 4. Okay, good. Because the denominators are the same, that is why we change to like fractions. Now we are getting like fractions here. 5/10 and 4/10. They are having the same denominator. Therefore, the fractions is like fraction. And when you are adding like fraction, you choose one of the denominator like what I did here, and then you add only the numerators here. Therefore, the 5 plus 4 will give you what? That will be 9/10. Okay, that will be 9/10. When they ask you to do the division, you pass through the same process. And then the subtraction, when you're asked to solve the subtraction side, like 1/2 minus 2/5, you do the same thing. You find, because here the 2 and the 5 are also not the same, so you need to find the LCD, and then you find the LCD. Like what we did here, the only thing that will change is what? The minus. So here is the A. Here is the A. The B will be what? will be 5 over 10 minus 4 over 10. You can either do it in a vertical form or horizontal way. Okay, so since the denominators are the same, you choose one of the denominators and then you add or you subtract the numerators. So one of the denominators have been chosen now, and then you subtract or you find the difference of the numerator, which will be 5 minus 4. When you are dealing with addition, then you close the brackets. Then when you perform the answer, you get what? Here will be 1 over 10. Okay, so even when it is addition or subtraction and the fractions are unlike fractions, you must pass through all the system to choose a common denominator. Then you rename the fraction to get common denominator here. After then you perform your actions or operations of addition or subtractions here. Okay, and this one too, the answer is 1 over 10. Okay, good. Let's quickly solve another example. When you are solving mixed fractions like this, here the denominators here are not the same. We have the 4 and the 5. So we call it unlike mixed fraction. When the denominators are the same, we call it like mixed fractions. But here is unlike mixed fractions here. So here the same procedure, but this time, because this one is a mixed fractions, you have to change to improper fractions, where the denominator will be smaller and the numerator will be bigger here. That is the improper fraction. Proper one is where the numerator is the smaller, or the number of the numerators are smaller than what the number of what the denominator. So that one, make note of that. Anytime you are solving for mixed fraction, you change to improper fractions, or you first perform the actions of the whole numbers, because now we have one whole number 3 over 4 plus 3 whole number 4 over 5. Since the whole numbers, let me write the solution first. Now, since the whole numbers are 1 on the other side and 3 on the other side, and the sign here means what? Addition. So you can easily add the whole number separate, and then you solve the fractions at their back. After then, you attach the whole number to the fraction that you get. Okay, I think that one will save you from converting from mixed fraction towards improper. But the best way that you have to do is that you change all mixed fractions to what? Improper fractions here. Now let's quickly add the whole numbers here. Once we have the whole numbers here to be the 1 plus 3, so we have gotten our whole number here to be 4. Okay, so the rare fraction that we are going to deal with is 3 over 4 plus 4 over 5. Good. Now, these fractions here are unlike fractions. So the first thing you have to do is that you find the LCM of 4 and 5. And finding the LCM, like what I said, you list the multiples of 4 the multiples of 5, and then you list the common multiples, and later you list the what? The lowest in the common multiples. When you say common multiple, the numbers that appears in the multiples of 4 and at the same time appears in the multiples of 5. Or you can either use the prime factorization method, the one that I'm going to use now. The prime factorization method here. Okay, good. To find the LCM of that. So let me quickly list. You're going to find the LCD, the least common denominator of 4 and what? And 5. So you have your 9's table. You construct your 9's table here. You have the 4 here and the 5 here. Good. Now you choose a number that can be cancelled, the 4 and 5 at the same time, because 4 is what? Even number, and 5 is odd number. You cannot get any straight number to do that. So you have to use the number themselves. Okay. So 4 cancel 4, 1. 4 cannot cancel 5. So we have to repeat the 5. Okay. Good. Now we are done with the 4 because you're supposed to reduce the numbers to 1. Then number to reduce this 5 to get 1 is the 5 itself here. So 5 cancel 5. Here you get 1. And then we have done with this one too. Okay. We have done with this one too. Therefore, the LCM is equal to the multiples of the numbers that we use to reduce the 5 and 4, which is 4 times 5. And that one is 20. So what does this 20 means? It means you should make sure that the denominators of the fractions that we have, 3/4 and 4/5, the denominator must change to 2020 so that the fractions will be like fractions. That process, we call it renaming. So you rename the fractions here, renaming. Okay, good. Oh, we call it renaming. Very good. So we are going to rename or give another name to these fractions here. Remember, we have already added what? The whole numbers. The whole number here was 1 and here was what? 3. Then you add the whole number separate. That one is another way to solve, or either you change all to improper fraction and then you start finding the LCD, or you can either ignore the whole number for a while, adding them. We have 4 here that we will bring back later. Now we are going to deal with these fractions after taking the whole numbers. So when you take the 3/4, then you leave a space. The new denominator that we are changing to like fraction must be 20. Okay, good. The new denominator must be equal to the LCM or the LCD. Then you take another fraction that you're going to rename. That one too is 4/5 then you leave a space here. The new denominator for 4/5, that will be equivalent to the first one, must also be 20, so that the fraction will balance. That will be like fractions here. After then, let's do the statistics. Now we know the old denominator of the 4 here, and we know the new denominator to be 20. So 4 times what number gave us this 20? Times 5 gave us that 20. In order to get this, and the same number that we multiply by the old denominator to get this 20 must be used to multiply the same numerator here. So the 3 will be used to multiply the 5, and that one will also be 15. Now, looking at this one again, we come back to the other one. We have to rename this one. We know the old denominator to be 5, the new one is 20. So multiply by what? Multiply by 4 will give us 20. The same numerator must be used to multiply the 4, so that the 4 times 4 will be what? 16. Good. So that the new numerator here will be 16. Good. Now, you have gotten 15/20 plus 16/20. They are now like fractions, okay? Good. And since the denominators are the same, then we add the numerators and choose one of the denominators. So we choose one of the denominators here, and then we add only the numerators, which is 16, 15 here, plus 16. Okay, good. Now, when you add the 16 plus 15, you get 31. Now, the answer here is 31/20. And you know the 31 is improper fraction, and you must also change 31 to 31/20 to mixed fraction. And don't forget we have the 4 here. So our main answer here, let's change this one before we add or we attach the 4 to the fractions here. Now we have the 31/20. If you want to change this one into mixed fraction, 20 goes into 31 how many times? Which will be 1. So you get 1 whole number here. The denominator will still remain the same. Okay. Then what will left in order to get 31 here? So 20 times 1 will be 20, plus what will be plus 11. Here will be 31. Okay, good. So we have 1 whole number, 11/20. And beside, we have 4 already here. So which will be 4 plus the new whole number here or plus the new whole number here against 11 over 20. Now the final answer will be 5 whole number 11 over 20. You add the first whole number that you added, the 1 plus 3, before dealing with only the fractions to avoid changing them. When you change all to improper fractions, so you still get the same answer. Okay, good. Now we can also solve the other one here. Now solve the fractions below. 8 whole number 1 over 8 and 5 whole number 3 over 4. Like what we did, we can easily subtract. We can easily subtract the whole numbers first, and then that one will be 8 when you solve it. Let me write the solution first. Good. Now with this, let's perform the actions of the whole numbers first. The whole numbers we have the 8 minus 5, and then that one will be what? 3. So we have the 3 as our answer. When you deal with the whole numbers, 8 minus 5, the 8 is here and the 5. Now we have gotten our 3 here. Therefore, we are going to deal with the 1 over 8 minus 3 over 4. Now, 1 over 8 and 3 over 4, they are all on like fractions, so you have to change to like fractions. So you write change to like fractions, okay, by finding the LCD or LCM of 8 and 4. Good. Now with this, I said we have two methods that we can use to deal with finding the LCM or the LCD. So you use the multiples method, whereby you list the multiples of 8. That is the M. You find the M. M means the multiples of 8, the multiples of 4. The first 10 multiples of 8, the first 10 multiples of 4. After then, you list the CM. The CM, that will be the common multiples, the numbers that appears in the multiples of 8 at the same time appears in the multiples of 4. After listing those numbers that are found in these two multiples, and then you list the L, which is the least or the lowest number in the common multiples. Are you okay? Good. Or you can easily use the prime factorization method to also to find your LCM. Okay, then you construct your nice table where you have the 8 and the 4 here. Okay, you construct a nice table for them. Good. Now you're going to reduce the 8 and 4. When you're using the prime factorization method, you reduce the 8 and 4 to get 1. And when you are dealing with that, you check the numbers, the two denominators here, the 8 and 4, they are all even numbers. So you must start with the 2. The 2 can reduce the 8 at the same time, can also reduce what? The 4. 2 can reduce all even numbers. Or you find a number that can cancel the 8 and at the same time, some people can also choose 4. It's accepted, but Omasinya choose 2 first. So 2 here, 2 cancel 8. 4 times the same 2 cancel 4 2 times. Okay, good. Then the 4 and 2, they are also even numbers. Then you can also use 2 to cancel the numbers. Okay, 2 goes into 4, 2, and 2 goes into this 2 here, 1, which means that we will not come back to this lane again. We have done with the 4. Left with the 2. What number do you think we can use to cancel the 2 to get 1? Is the 2 is 7? Okay, then 2 cancel 2 here, 1, and then we have done. Always check whether the numbers, we have a common number to cancel them first. Very good. Now, when you are done, the LCM will be the multiples of the numbers that we use to cancel the 8 and 4. So the LCD or the LCM is 2 times 2 times 2. And that one is 2 times 2 is 4. 4 times 2 is what? 8. So the LCM is 8. Okay. Or the LCD is 8, which means that the denominator is supposed to be named to 8, 8. Good. Now, when you have the rename, here, or renaming, okay, you rename the fraction so that they will all have the same what denominator here. Okay, good. Now looking at this one, when you take the first one, is 1 over 8. You're going to make sure that the denominator will be what? Will be 8. Good. Then you take the other fractions, which is 3 over 4. Then you leave a space. The new denominator must be 8. Okay, good. Now with this, you're going to deal with the numerators here. Now we have 8 here, 8 here, which means that this 8 was multiplied by 1 before getting that. the same thing must multiply by the numerator here so that we can get a number here. So therefore here is also 1/8. Then when you come to the other side, we have the 2 here. The 4 multiplied by the 2 give us 8. The same 2 must be used to multiply the numerator here. And that one will also be 6. It will be 6. Good. Now, the fractions are now like fractions. Then you perform the actions where you have your 1/8 minus 6/8. Okay, good. 6/8. Then we have here is what? 8. Since the numerators are the same, then we subtract the what? Since the denominators are the same, we subtract the numerators here. Good. I remember we have a positive 3 here. So let's deal with this one amicably. Now you choose one of the denominator, which is the 8, and then you perform the actions of here. 1 minus 6 here, and that one will be -5. That is minus 5 over what? 8. But we have a positive 3 already here. So we have the 3 minus of 5/8. Okay. Every whole number is over 1. So when you find the LCM of 1 and 8, it's still what? 8. Okay. So you rename this one, and this one will be 8 times 3. That will be 24. Minus 5. Okay. Therefore, you subtract, you get what? 19, right? You get 19/8. With the 19/8, you have to change them to improper fraction. So you have to change. So 8 goes into 19. You work that one out. So 19 divided by 8. So it will be 8 goes into 19 2 times. Okay. So you get your 2 whole number here. Then the denominator will still remain 8. So 8 times 2 will give you what? 16. So when you have the 16 minus 19, you get what? 3. So now you have the 3 as a numerator here. So the final answer is 2 whole number here 3/8. But the only thing that will help you is that I said always change all mixed fractions to what? Improper fractions before you solve. That is the best way you can solve, okay? Especially when you are dealing with the addition and subtractions. Okay, good. Thank you.